it is our pleasure that respected Professor B.D. Gaikwad sir will guide us in this creative design and thinking guest session. I think the creative design and thinking teachers might have conducted lectures on your division about the mind mapping, then related with the second assignment, and it was uh, empathy mapping. Okay, third is the convergent and divergent thinking process. So almost 1, 2, or all 3 assignments, it has been already discussed with you. Now, I think your teachers might have given the submission link also. If they have not given, you can ask for the assignment submission link and you can submit your assignment over there. First assignment will be on the mind mapping, and second will be on empathy mapping. Third is on the convergent and divergent thinking. Okay, so students from A to D division, I think they are joining this lecture. Many of them have joined it. So within few minutes, respected Professor B.D. Gaikwad sir will come over here on this online platform and he will guide you about creative design and thinking. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Second thing, as far as the D division is concerned, I had given a link to submit the assignment yesterday, and today I'm going to close it at 7 p.m. 44 students have given their. So I request you all, please submit both assignment 1 and assignment 2 separately. Separately, you need to submit the assignment number 1 and then assignment number 2. Assignment number 1 is on mind mapping. Assignment number 2 on empathy mapping. Okay, both assignments separately you need to submit. If you have submitted in only one link, then I request you submit second assignment once again by using same link. Is it clear to everybody, D division student?
Yes, sir.
Yes, sir.
So up to today 7 p.m. there is a time to submit the assignment. Means after completion of our lectures, 4 to 7 p.m. 3 hours are there. If you have not completed assignment yesterday, then you can complete it and submit it up to today 7 p.m. Is it clear to everybody?
Yes, sir.
Yes, sir.
Okay, thank you. Yes.
Good morning, everyone.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning.
I hope voice is clear to all.
Yes, sir.
Yes, sir.
Okay. Uh, Today we have arranged the guest lecture on creativity and design thinking. Already Yashpal sir have discussed about the today's speaker. So who is going to deliver the session? So just I will add 2 to 3 points and then we will start the session. So today the session on creativity and design thinking. The topic sir is going to cover that it is product design, its process and testing. So I will introduce the sir, Professor B.D. Gaikwad sir, presently working as associate professor in mechanical engineering department. He has completed M.Tech in production engineering from IIT Delhi. Sir has total industrial experience of 13 years and teaching experience 17 years. So very experienced person we have got for the expert lecture or the guest lecture on this subject, creativity and design thinking. Presently, sir is handling one additional charge, that is a workshop in charge of mechanical engineering department. So such a experienced person who has industrial as well as teaching experience. So without wasting much of the time, I first of all, so I welcome Professor B.D. Gaikwad sir on behalf of Industrial Engineering Department to deliver this session on the creativity and design thinking. So welcome, sir.
Thank you. Thank you and good mornings to all of you.
Good morning,
Okay, my sound is audible.
Yes, sir.
Yes, sir. Yes, sir.
Yes.
Yes, sir.
Shall I start?
Yes.
Yes, sir.
Yes, sir.
हा 1-2 मिनिट थांबा. हॅलो, काय म्हणताय? हा, विद्यार्थ्यांना जॉईन होता येत नाही सर. काय झालं? काय म्हणताय? 219 झालेले आहेत आत्ताशी, 300 ची स्ट्रेंथ आहे. त्यांच्या मोबाईलला लॉग इन करून जॉईन व्हायला सांगा. काय?
Okay, thank you once again and good mornings to all of you. So here I am in front of shall I start? Okay. Here I am in front of one of the developed machines by me, and designs and development that is done by me in industry, and related expenditures we have got from the uh, Rajiv Gandhi Science and Technology Commission, Mumbai. So this is the funded project, and we have received 15 lakhs rupees from Rajiv Gandhi Science and Technology Commission, Mumbai. So this is the one of the machines I have designs and developed, which is useful for the conveyors, which is used in our sugar industry. At the same time, same machines can test the all types of conveyors, which is used in fertilizer plant, sugar industry, the paper industry, oil industry, solvent industry, and whenever continuous processing units are there, high production is there, here we can use to test the various types of conveyors which is used in our industry. So while designing this machine, I have taken one reference from our Indian standards. Every product there is a Indian standards. So here's conveyors. It is also one of the product, and it is standardized by the Indian standards. Initially, the manufacturing that is done in the manufacturing units in the various industry in the Maharashtra or outside the Maharashtra. But main motto before using this conveyors in the any continuous types of industry, maybe sugar industry, fertilizer industry, solvent industry, paper industry, the conveyor must be tested by the one of the technology, and some of the characteristics of the conveyor, it has been based upon the preloading, length measuring, and breaking loads of conveyor chains. So once the chains, this conveyor chains will get passed through these three tests, which are three tests: preloading, length measuring, and breaking loads. And once these conveyors will go through this test, and if all these tests will get positive result as per the Indian standards, then this type of conveyors, it is allows to work in that particular industry. Otherwise, if will not go for testing these three characteristic of the conveyors, definitely there is a inherent problems in that particular industry, and there is a huge loss. This is a not only loss of the manufacturers or the owners, but this is the ultimately loss of our farmers. For example, the sugar industry, different types of conveyors it has been used. You might have seen. This is one of the conveyor. Initially, once the tractor scan parts will get dumped over the conveyors, it will go to the crushing units. After that, the bagasse will come out. It will go to the outside the factory for drying purpose. There is one conveyor. After drying, this bagasse will go return back to the boiler units. So this is also one of the conveyors. And after the sugars manufactured nearer to that boilers, in order to increase the flowability of this, we require the bucket elevator conveyor change. And once that sugar parts, once we achieve that flowability, then it will get filled in gunny bags, and that gunny bags we will have to keep in store of the sugar industry. So every station there is a conveyor, but certain conveyors, if the problems will occurs, definitely this link will get break. And once this link will get break, there is a huge loss of that industry. There is huge loss of farmers. Okay. So around us, many sugar industries are there. And I have studied the problems of that sugar industry. And with this concept, I have given one project to the Rajiv Gandhi Science and Technology Commission, Mumbai. And this project, it has been granted by these commissions, and I have got that rupees as a funds to develop such type of machines. And I have accordingly developed such machines which is useful to our sugar industry. So just to see this, I am in front of this machine. This machine name is called preloading and length measuring machines. Actually, in the any conveyors, not only in conveyors but also driving chains, there is a difference between conveyor chain and driving chains. Your cycle chain, motorcycle chains, these chains, it comes under the driving, power driving purpose. But this conveyor chain, it is normally used to transport the material from one place to the next place. Okay. In many automation industry, continuous productions type of industry, without these conveyors, that industry will not work. Whenever automation part is there, the vital part of conveyors always be in that particular industry. So in order to work this uh, continuous or mass production or automotive types of industry continuously, uh, there must be reliability in that particular conveyors. To get the reliability from the conveyors, we actually need to go through the preloading, length measuring, and testing of the braking loads as per the Indian standards. So just I will explain the uh, this preloading length measuring machines construction parts and how we can measure the uh, length of chains and how we can go for preloadings. Okay. So as per Indian standards, the chain has been designed, conveyor chain has been designed on basis of braking loads. And braking load is depends upon the capacity of the conveyors. Capacity of the conveyors, that means how much ton of the loads it can be transferred from one place to the next place within 1 hour. So this is the capacity of transporting materials. On this capacity, it has been useful to go through the different criteria of deciding the braking load of the conveyor chains. Means initially we require the capacity of conveyors. For example, once again I will repeat, within the 24 hours, how much the ton material it can be transferred from one place to the next place, that is the capacity of the conveyor. And on this basis we can decide the braking load. For example, suppose we have decided a braking load is 60 tons. 60 tons braking load is there. So this braking load we can test on universal tensile testing machines. You might have seen, or if you will personally visit in our college, you will have to see such universal tensile testing machines. So here we can test the conveyor chain, and through the trace train graphs, we will get the idea about the braking loads. Okay. So once we got that braking loads, and as per the design of the Indian standards, if that chain will give that braking loads, then we will say that that conveyor is okay to work further. But this only one character is not sufficient, because while working the conveyors, there must be certain elongations, and that elongations should not go the behind the limitation set by the Indian standards. So what is that limitations? Limitation is there 3000 mm length of chain is there, then allowable elongation, that is 7.5 mm. This is the allowable elongations in the manufacturing stage. Means those are manufacturing the conveyors. That industry, actually it is expected to test that conveyor to fulfill the requirement of Indian standard. What is the requirement of Indian standard? So 3000 mm, if conveyor length is there, after applying the loads, it should not cross the limit of 7.5 mm. But there should be a load. So which load we can apply on this length measuring? We have got actually braking load. So braking load divided by 50, whatever loads will come, that loads we have to apply on the conveyor, and we have to measure the elongation. And if that elongation is less than 7.5 mm, then we say that this conveyor definitely works for particular periods in the industry. So this is the second criteria. First criteria, braking load. Second criteria, length measuring. Then what is the preloading? Preloading, see that in the conveyor manufacturing industry, different types of operations are taking place. Maybe the piercing, blanking, cropping, heat treatments, and assembly. So while making any chain, maybe your cycle chain, motorcycle chains, or the conveyor chains, while making the chains, there is actually working traces. It has been developed in the manufacturing. So because of the operation, maybe press tooling operations, maybe forging operations, maybe cropping operation, maybe piercing or blankings, too many operations are there. Heat treatment operations are there. So because of this working trace, it has been developed in the conveyors or chain itself. So there is a need to remove this working traces. Otherwise, what will happen if we will not remove that working traces? Definitely that change will get stuck in the working conditions. Means it will not work on the sprocket, and definitely because of tightness, sometimes this change in the running condition, it will get break. So this preloading characteristic we have to justify with this with help of this machine. So now how to calculate preload? So initially we have decided braking load. We have also tested braking load 60 tons we have considered. So 60 divided by 1/3. Okay. So around 20 tons we can apply these loads on that chain, and we can rotate the chains in that load condition. This is actually working loads in the industry. Means braking load is 60, then 1/3 means 20. This is the working load in the industry. Okay, means initially in the manufacturing stage, we have to test the working load, that is nothing but preloading. Okay, so once these conveyors will pass through these three tests, which are three tests: braking load, length measuring, and preloading. Once these conveyors will fulfill this requirement, which is set by Indian standards, then these conveyors will allow to set or install in that sugar industry, paper mills, cement industry, oil industry, solvent plants. Okay. Otherwise, if we are not tested these three tests, definitely in working condition, this conveyors will get break, and there is a huge loss of that industry. To avoid this loss, each conveyors need to test three types of tests, that is the braking load, then length measuring, and preloading. Okay, so braking loads we can test on UTM machine, universal tensile testing machines, which is a different machines. It is available in our college, but I have got one more machines. Just I am in front of this machines. I have designed and developed with help of Rajiv Gandhi Science and Technology Commission, Mumbai. Total expenditures for this machine 3,50,000. So what is actually designs? Just I will show the structure of these machines. So here's this is the control panels. This is the control panel is there. Here is the pressure gauge is there. Pressure setter is there. We can adjust these pressures. Okay. So how calculate these pressures? You know that pressures, this is equal to force upon cross section area. Okay. Now I want to go for length measuring. Okay, length measuring, how much load we can apply? Braking load divided by 50. So 60-ton braking load is there, divided by 50. What is that 50? This is actually experimentally calculated value and set the Indian standards. So as it is formula we have taken here. So braking load divided by 50. Okay, so this is your length measuring loads. Now you know that pressures, that is equal to force upon cross section area. Force definitely will get 60 divided by 60 tons divided by 50, you will get that load. That load is nothing but force. But what is that A? Force upon A. A means working area of the cylinders. Now if you see this machine, here is one cylinder is there. Is a hydraulic cylinder is there. Okay. Is it visible to you? Hello?
Yes, sir.
Yes, sir.
Cylinder is there. Inside that,
No,
the
sir.
piston and piston rod is there.
No,
It is
sir.
visible.
Not
Sir.
visible.
No, sir. Not visible, sir.
Now it is visible.
No, sir.
No, sir.
No, sir.
No, sir.
Yes, sir.
Hand is there.
Yes, sir.
Yes,
Yes, sir.
Just see that position
Yes, sir.
of my hand. So here is one cylinder. Okay. Inside that piston and piston rod is
Sir,
there.
it is not visible.
Of course, it is inside the machines, but just I have touched to that cylinder. My fingers on the cylinder. My fingers are visible.
Yes, sir.
Yes,
Okay.
Visible, sir. Visible.
Yes, sir.
Okay. The cylinder is inside this. Inside this machine.
Visible.
Hello,
Hello. Any problem?
sir. Sir, video is not visible to division D. Also, yes.
Not equal to
Yes,
zero.
sir.
Also see, sir.
Yes, sir.
Okay. Okay.
Screen push left side.
B division problem. Shall we wait? Now it is visible B division.
Yes, sir.
Yes, sir.
Okay. Okay.
Yes, sir.
Now just I have touched to this cylinder. This is a hydraulic cylinder. In cylinder there is a piston and piston rod. So working area of that cylinders we have to calculate. How to calculate the working area? The bore size of cylinder minus the piston and piston rod area we have to deduct. So you will get working area. So that is called A. Correct? So force upon area, that is the pressure. Okay. Force from where we have got? Force braking load divided by 50. This is the force. And A means working area of the cylinder. How to calculate? Bore area we have to calculate minus piston area minus piston rod area. You will get A. So force divided by A, you will get that pressures. So this is the pressure dials. Okay. So this is the pressure dials. With help of this, we can adjust pressure. Suppose pressure is around 50. Then we can adjust here. Okay. So that means on that particular length measuring loads, we have applied the loads on the chain. Correct. So here is the, in this machine, where is the chain actually? Here is one shaft. Just can you see my fingers? Yes. So
Yes,
here is one shaft. And if you go back side, there is also one more shaft. And inside the machines, there are 4 sprocket. Okay, have you seen the sprocket? Hello?
Yes, sir. Yes, sir.
Otherwise, I will show there is a sprocket, sphere sprocket with us. So this is the sprockets, correct? So here sphere sprocket with us. Such a sphere sprocket, it is called sprocket chain. Your cycle chain also having a sprocket. Similar types of sprockets are there, and all these sprocket normally in these machines you can see in this side. So here is one sprocket. At the bottom, one more sprocket is there. At the top, one more sprocket, and backside, one more sprocket is there. So totally 4 sprockets are there. One is the driving sprocket at the backside, and this is the driven sprocket. So here's one sprocket. It is mounted on this driving shaft, and this is the driven shaft. Okay. And here is one attachments I have made here, which is attached to the dial gauge. Here is the dial gauge, and here is the normally slot provided in order to get the displacement of this shaft. Means in this machine, backside shaft is fixed shaft. Okay, but this shaft, it is movable in the horizontal direction. Okay, and the moment it has been trapped by the dial gauge. Okay, so here is the dial gauge, but this dial gauge we have to calibrate. Calibration means what displacement, how much division. For example, 1 mm displacement is there. Just you can see here. So just applying this particular force on the spindle of the dial will get moved. Okay. So this dial we have to calibrate. Calibrate means how much displacement, how much division. Okay. So this movable shaft and peak shaft having a sprocket and 2 sprocket at the center, that is called idlers. So our tested conveyor to be tested, which is mounted on the sprocket. So this is the conveyor. So it is visible. This is
Yes,
the
sir.
conveyor.
Yes,
It is
sir.
mounted on the sprocket, and this conveyors will get rotate. Now I will start the machine. You will have to see this working of the machines. Now conveyor is working on the 4 sprocket. Out of 4, 2 sprocket are idlers. One sprocket that is on the driving shaft, and 1 sprocket on the driven shaft. Okay, and over this driven shaft, one dial gauge that is mounted, means the displacement of such shaft we can measure with help of dial gauge. Okay, so initially we can set the pressures as per the criteria of the Indian standard, that is braking load divided by 50. So this will get force. The force upon area. Area means our hydraulic cylinder area we have to calculate. So force upon area, that will get pressure. This pressure here we have to set, adjust these buttons. That means whatever load which is decided by Indian standard, it is actually on the conveyor. Okay, and we can go on rotating this sprocket. If there is certain problem in that conveyor, then elongations will cross the limitation which is set by the Indian standard. Means the length of conveyor is 3000 mm. In the working load conditions, working load condition means load of our measurement loads, length measuring loads, that is 60 divided by 50. So once this load will apply on the conveyor, if the conveyors will cross the limit of 7.5, means 3000 mm conveyor is there, allowable elongation is 7.5. Okay, but even the number of rotation, if the limit will not cross, means this dial will not move, correct, it will remain as it is. That means elongation is coming below the 7.5. That means this chain is passed and it is useful for working in industry. Okay, similarly we can preload the conveyors. Preload conveyors means we have to test that conveyors as per the working load used in industry. So this working load, how to calculate? 1/3 of the braking load. So 60-ton braking load is there, divided by 3, that is the 20. So 20, this is our force. Force divided by working area of the cylinder, you will get the pressure. Okay, force divided by working area of the cylinders, you will get the pressure. You can set the pressure, go on rotating this conveyor. If problem is not there, definitely the joint which is occurs in the conveyors, for example, so you can see the in conveyors number of joints are there. Here is one joint, second joint is there, third joints are, like the joints are there, and it is expected to rotate these conveyor links about these joints. If rotating is not there, sometimes what will happen, this sprocket or the conveyors will get a jam, and there is a possibility to break that conveyor. Means all joint of this conveyor, it is expected to rotate easily. That is called articulation in our English language, easy to move. Okay, and this articulations, this point it comes under the preloading. So before length measuring, we have to lose this joint, means we have to remove the working traces in the manufacturing, lose these joints, and this conveyor, it is expected to rotate easily on the sprocket. So this is the preloading. Preloading formula, working load, force divided by area. What is the force? Preloading purpose as per Indian standard, braking load divided by 3. So this is a force, and A means working area of the cylinder. You will get the pressure. That pressure we have to set on the this dial gauge, and we can go on rotating this. So such two tests we can test in these machines. Is it correct? Anybody having any problems up to here?
No, sir.
Hello.
Yes.
No, sir.
Anybody having any problems up to here? It is clear.
Yes, sir. Yes, sir.
This is
Okay. Is it necessary to repeat or not? Or shall I repeat once again in short?
So in short.
Or not necessary?
Yes, sir. Yes.
Okay, in short, once again I will repeat. So this machine having 4 sprocket. So you can see my hand at the center, top and bottom, 2 sprocket are there. That is called idlers. And this, see my fingers, this is one shaft, and on this shaft inside the machine 1 sprocket is there. And if you go horizontally at the back side, there is one more shaft. Just I will touch to that shaft. You can see through this camera. So here is the shaft, correct? So this is one shaft, and before a few minutes I have touched that shaft. This shaft and that forward shaft, it is in one line. So here's one more sprocket inside is there, and this shaft, it is rotated by gear drive. The motor is there. So here you can see this side there is a motor, coupling is there, and here is the shaft. Okay, once this motor will start, the shaft inside this, it will get rotate, sprocket will get rotate, the conveyors will get rotate. And this unit, it is power pack unit. So what is use of power pack unit? Inside the machine, one hydraulic cylinder is there. Forward and backward movement of the piston, that is done by this hydraulic power pack unit. Okay, this is the hydraulic power pack unit. Means these motors, it is only used for rotating the sprocket, and this motor along with this tub, it is used to give the force on the conveyor. Okay, this power pack unit, it is used to give the force on the conveyor through the sprocket, which is mounted on that shaft. So these two devices are there. This is for driving to the shaft and sprocket over this, and this power pack unit, it is expected to move these conveyors in the horizontal direction once the slackness will get developed in the conveyor. Okay, so these two important things are there. So with these two devices, we can measure the length of a chain in initial condition for 3000 mm. 3000 mm means length of this conveyors. If you put this conveyors on the ground and with help of tape or the unit in mm, if you measure this conveyor, the conveyor length is 3000 mm. And if you applied this measuring loads, so this conveyor should not cross the limit, means 3000 and 7.5 mm. Okay, if you cross this limit, that means conveyor is not useful to work in any industry. We can reject that conveyor there itself. And even though if you are not tested, the problem will create in the running condition, and there is huge loss of that industry. Okay, so initially we have to test this conveyors in the manufacturing stage. For this purpose, we have developed this machine, and it is very simple. Two shafts are there, two idlers are there. One shaft rotate along with the sprocket, second shaft having a sprocket, but along with the rotation movement, the horizontal movement of this shaft is there. The horizontal movement of this shaft, it is measured by the dials. Okay, and load is given on these panels by calculating the pressures. Okay, so pressure means particular loads. Particular loads means that braking load divided by 50, which is the formula of Indian standard. And pressure, how to calculate? This load divided by working area of the cylinder, hydraulic cylinder. Here you will get the pressure. That means this much load we have applied on the conveyor, and after applying the loads, how much the elongations of the chain is there, it is measured by calibrated dial gauge. So this is the concept of our preloading and length measuring machines. Okay, so up to here it is clear, or anybody having any doubt? You want to see in the working conditions? Huh? Have you seen in the working condition, or shall I
Yes.
repeat in the working condition? Hello?
Seen, sir.
Sir, it is seen.
Okay, I will once again I will show this both sides. You can see in the back side also. Here. Is it okay now?
Yes,
Okay.
sir.
Yes.
Now,
Yes, sir.
one more thing. One more things I have done here. you might have seen our bicycle chain or motorcycle chains. There is a number of joint. Now you can see here conveyors also having a joints. Now I will show the one more application of these machines. So I will show to you. See that here it is visible. My fingers, I have touched the two pin of the conveyors. Is it visible?
Yes, sir.
Yes, sir.
Sir.
Yes, sir.
One pin, this is second pin, and this is the conveyor link. Okay, so here white marks are there, and here is one stand is there. So this is one more stand, this is second stand. Actually what we have done here, I have kept here one sensor. So here's there is a place for sensor. Here is also place for sensor, and the sensor, this is actually laser technology. With help of this sensor, this pin with this sensor, this pin with this sensor, actually this distance will get measured. Are you getting the distance between these two pin? It is measured initially with a laser sensor. Okay, and this sensor, it is attached to the computers. It is attached to the computers. So initially this distance, suppose 150, suppose we have got this distance with sensor on computer 150. Okay, now you can start this machine. The number of links, it will come in front of sensor. Now just I will remove the small movement of this conveyor. Now next link will be there. Is it correct? Next link will be there. Okay, whenever the white colors 2 point, it will come in front of sensor. That distance it is measured and it is visible on the computers with help of laser technology. In such way, in this situation, you can go on rotating this conveyors number of revolutions. Okay, and you can develop the graph. Okay, so which type of graphs will be there? So I will show here one more graph is there. Here, number of revolutions versus elongations. Number of revolution means the chain will go on rotating and the elongation will take place. So here elongations, it will goes on increasing, and here is the maximum limit, and corresponding is the revolution. Okay, maximum limit corresponding is revolution. Means from 0 to this much revolution, you can make use of this conveyor. Okay, you can make use of this conveyor, and after that you can replace this conveyors. Otherwise the chain will get break. Okay, so from this graph we can conclude that you can run this conveyors up to this elongations. Up to this elongation, you can give the elongation of 7.5 like this way. Indian standard 7.5 elongation is there. So this maximum point 7.5, once that elongation we get, then you have to stop the working of that conveyor. Otherwise you can go on working. Means that conveyor's revolutions you can continue unless and until you are not getting the 7.5 elongation. So this is one more the research part we have done in this preloading and length measuring machines. So three characteristics of the conveyor chains we have tested: elongation versus revolutions, second preloading and length measuring. Okay, so preloading, length measuring and elongation, this part it is expected to test the conveyor in the manufacturing stage, and then we can allow that conveyor to install in the sugar industry, fertilizer industry, paper mills, oil mills. Okay, whenever consumable or automation part is there, you can allow this conveyor. Okay, so on this machine also we have filed one patent also. See that So this is the chart. We have filed this patent. Indian patent is there. We are waiting for the result of this. And at the same time, our 8 students done that research work with help of this machine, M.Tech students. So here is the list of the M.Tech students. They have made the research work related to this machine. And here's the breaking load testing. This is the UTM machines which is exist in our college. 100-ton capacity is there. And this is actually conveyor chains we have tested. This is the breaking part. Pin has broken under that particular loads. So breaking test, this is actually expected to detect the capacity of the conveyor. Okay. So once this breaking load is 60 ton as per Indian standard, if it is 60 ton as per Indian standard, means this conveyor will get break 60 or above that, then this conveyor is okay for conveying this material. But at the same time, we can go for preloading, length measuring, so that working durations you will get through this. So in short, with help of these machines, we can get the duration of the conveyors, means particular capacity of the conveyor, means 25 times 4 hours load transporting capacity is there, then how much periods that conveyors will work there. And before breaking, we can test that, and we can replace that also. Means once we purchase that conveyors and it is fulfilled these 3 characteristics, and we can decide the how much years we can make use of that conveyor. Okay. Before failures, we can get the intimations of this conveyor. So this machine patent we have filed. Our ME students also, they have done the ME with help of this machine research work. At the same time, so you can see here, Honorables, the Padma Vibhushans, Dr. Anil Kakotkars, Dr. Chidambarams, they have visited to this lab. You can see the photographs of this lab. So our the Honorable Dr. Chidambarams, Indian scientist, has visited to this lab. At the same time, Padma Vibhushans, Dr. Anil Kakotkar also visited this lab. So this lab, it is useful to our farmers, useful to sugar industry, and we have made the survey and we have developed such machines which is useful to our sugar industry. Okay, and one more research works we have done in the conveyor also. You can see in sugar industry, initial conveyors, that is cane carrier conveyors, means tractors or trucks, once they will dump that sugar cane on the conveyor. There is one conveyor that is called cane carrier conveyor. Now you can see here, this is one conveyor. So we have gone through the optimization of the conveyors. So nowadays, if you visit the sugar industry, you will have to see the such type of conveyor initial stage where sugar cane will dump in the initial stage. That conveyor, that is called sugar cane carriers conveyor. So here you can see the curves are there, number of curves are there. See my fingers, curves are there. But nowadays, if you visit to sugar industry, curves are not there. But I have given suggestions to the manufacturer. You can make the curve like this way, so that what will happen, the per meters weight of the conveyor chains will get reduced. Per meter weight of the conveyor chain will get reduced. And you might have known, in sugar industry, length of conveyor is more than 300 meters. So that much loads of that conveyors will reduce, and that loads, it will helps to reduce the power of the sugar industry. And once the power of sugar industry will get reduced, the manufacturing cost of sugars will get reduced. So this is also one of the developments I have made in this lab. So here's conveyor optimizations, maybe bagasse carrier or cane carrier chains. Here's I have done one samples without affecting the braking loads, without affecting the capacity of the conveyors. I have reduced the weight of the per meter conveyors by providing the slot. Where I have provided not useful place, I have provided this slot. Means there is no effect on the quality of the product, braking load of the product, capacity of the product. We can reduce the weight of the conveyor. This is also called as one of the value engineering technique. Value we can increase, reducing the cost. So cost also will get decreased, means per meter weight will decrease, that raw material cost also will get reduced. At the same time, power is required to drive the conveyor. Once the weight of the conveyor will reduce, power that is automatically will reduce, because you know that power that is equal to force into the velocity, and force is also that is depends upon the weight, how much force is required to move the conveyor. But if you reduce the weight of the conveyor, definitely powers will get reduced. And once the power will get reduced, the manufacturing cost of sugar will get reduced. And this is useful to our farmer also. So whatever the research works I have done from the viewpoint of our surrounding area, farmers, the working conditions, and the economical conditions of our Maharashtra and India also. So if you think that how to get the economical things to our farmers, then it is also ultimately effect on the economic conditions of the India. So whatever the research works in these labs I have done, this is related to our directly farmers. Okay, means power we can reduce without breaking. We can run the conveyors, no loss of the times and no loss of the these farmers, the whatever money pendings in that sugar industry. So this is the research works I have made in this lab. Whenever you will come to college, personally visit to our workshop, and you can see the actually working of this preloading and length measuring machines. So here's I have done optimization of the conveyors, length measuring of the conveyors, preloadings of the conveyors, and braking load testing of the conveyors. We have filed the patents. Our ME students, they have done their project reports. But one more things I would like to suggest you. This machine, it is expected to make it portable. So anybody is interested in this research, come forwards with your idea. So if that idea is good, it is acceptable to this, then once again we'll write this project to this Rajiv Gandhi Technology Commissions, Mumbai. And if these machines, once it will become portable, then it is easy to move to the working place in the sugar industry, and we can test the conveyors. And before breaking, we can give the intimations to the chief engineers of the sugar industry. So this is about this our labs. Okay, anybody having any problems?
No, sir. No, sir.
Okay, thank you.
No, sir.
No, sir.
Times visit to our workshop, and you can see and try to remember the explanation. And one challenge to you, make this machine portable. Okay, if anybody having a nice idea, you come with idea, discuss with me, and with help of particular fundings, we can develop the portable machine, so that every sugar industry within the few hours we can test the conveyors. Okay, thank you. Very nice day. Thank you once again.
Thank you, sir.
Thank you, Professor.
Yes, sir.
Thank you, Professor B.D. Gaikwad, sir, for giving the valuable time and delivering the lecture to the first year students. So definitely, sir Sir, I will assure that our as subject creativity and design thinking, our student will start implementing and they will start thinking. And as you are the inspiration or the motivation for our students and the faculty of the creativity and design thinking. So definitely, sir, we'll start in that direction. So once again, I'm thankful to Dr. Lindway sir for allowing us to arrange this guest lecture to the first year students, as well as all the subject teachers, CDT teachers, for cooperating this guest lecture, for conducting this lecture successfully. I'm also thankful to Dr. H.H. Pawar sir for arranging this online session with the different devices. So I'm also thankful to all the students for attending this session very calm and patiently. Thank you. Thank you one and all. Now I declare that this session is over. You can have 1 hour lunch break, and after 1 hour you can join the regular lecture as per the timetable. Okay, thank you very much.
Okay, sir.
Now all can leave the meeting.
Yes, sir.
Yes.